So, and I think the blue color is basically the energy bleeding off as a Curtate cycloid cosine function.
Oh, okay. All right.
So that's what I think is going on. In a perfectly pure vacuum, you get a Curtate cycloid, but then as that energy, as that particle moves into a medium that's to any medium at all that has elasticity, then what you're getting is then it transforms gradually into a sine wave, and you're giving off the energy in the blue range of the visual spectrum.
Mm-hmm. And that sine wave is basically forced upon the cycloid by the medium. Because
the medium then becomes more influential
yes.
in determining what the electron has energy, but it's in a completely different medium. So now the influence of the electric and the magnetic fields are less important,
yes.
and the elasticity of the medium is more important.
Okay. All right. I'm still not quite comprehending though why you say that the vibration. Are you saying the field is more important than the vibration? Is that what you're saying?
The distinction is between the field and the medium.
Okay.
The field,
right.
The field is the gradient between the two poles of the magnet. That's the magnetic field.
Mm-hmm.
Or it's the gradient between the filament and the grid, not the filament and the grid and the plate in a vacuum tube. But the medium is exactly that. It's what you're bouncing around in.
Mm-hmm.
What that has to do is there's an area called collision theory, and it has to do with a mean free path. I think it was Thomson who made this remark that he had to, the devices that he felt that he used to prove that electrons were particles, he said that in order to get determinate behavior, the mean free path had to be a lot less than a centimeter so that the collisions were very infrequent.
Okay.
When the mean free path is real long, then you get a lot of collisions and you blow out, you lose the trajectory. So in other words, your skepticism, the skepticism that you're expressing, you're saying, well, I don't think chaos theory is going to give you that the chalk on a blackboard motion.
Okay.
Your intuition, Pastor, is completely correct. But the reason that the motion blurs is because you start getting collisions, and the collisions impart energy in different directions.
Okay.
So that's where you lose your that's where you start to lose the beautiful, elegant geometrical type figures. Those get lost, but it's not because the theory is corrupt. It's because you're seeing collisions.
Okay. Okay, I see. So we're back to the pool table analogy, where the billiard ball hits the rack, and they go all in different directions, but then they reorganize. And is that would that be a safe way of describing a particle or a piece of matter?
Yes, but the reason you're skeptical from what you see on a billiard board on a billiard table is there's no field.
Yes. Right. Okay.
The field. Now, let me explain. On a billiard table, there's the gravitational field,
yes.
but it's completely canceled out because the billiard table is perfectly flat.
Right.
Right. So, in other words, the energy of the collisions disturbs the pattern of the balls when you're playing billiards. The energy does that, but there's no acting of the field because
either from
the field
above or below. Yeah.
Yep.
Okay. I see. All right. Interesting. Okay. So how did Einstein did he steal the concept of the concept Lorentz had about relativity? How many other people before Einstein had this concept before he eventually plagiarized it?
Well, okay, now what you have to understand is that Einstein was not given the Nobel Prize just for relativity theory.
Okay.
So let me quote. I'm going to quote now from the people who gave the speech. They said he was given it for his efforts with relativity theory, Brownian motion, quantum mechanics, and the photoelectric effect. So in other words, relativity theory was always a weak sister.
Okay.
It was always something that was a little bit shady.
Okay.
So the Nobel Prize committee said, Albert, you're a Jew. You deserve a Nobel Prize. You're the Al Gore of 1922.
Yeah, right.
We've got to give you a Nobel Prize because you're a Jew, just like Al Gore.
Yes.
But now think about Al Gore. Al Gore is claiming that we're in the middle of global warming,
And he invented
but the last
internet.
10 years have been the coldest years in recorded history.
Right, exactly.
And he won a Nobel Prize. So it's the same. It was the same thing then. A Jew had to be the one to win the Nobel Prize.
Yeah.
So Einstein basically codified certain issues, discussions. Even the Lorentz contraction was not original to Lorentz.
Mm-hmm.
Oliver Heaviside came up with it in around 1888. And Lorentz finally codified it in his book in 1902. But Lorentz was the more legitimate scientist. Lorentz was the guy with the faculty appointment. Heaviside was the guy who was he did inventions in his basement.
Okay.
You see?
Yeah.
So the issue is, how do you look? Do you look like a tenured faculty appointment guy, or do you look like a guy who's an eccentric inventor?
Yeah. Well, one of them was the real mathematician. Right. Okay.
Well, Lorentz was a better mathematician than Einstein.
Okay.
It probably is true that Einstein's wife did the math for most of his earliest papers.
Okay. Okay. So where does it leave us with the famous equation E equals mc squared? And the concept is that c, the speed of light, is constant. Is that true or not?
Okay, the speed of light depends on what medium you're in.
Okay.
So the speed of light in an absolute vacuum is real darn fast.
Okay.
When you're in water, the speed of light is a lot slower.
Mm-hmm.
You see, because it depends on the density. So
Right.
Einstein's E equals mc squared, that's actually the formula for kinetic energy, because kinetic energy is 1/2 mass times the square of the velocity.
Okay.
You see, so Einstein just put different symbols in an equation that had been around for a long time.
Okay.
See, he was predicting. Let me tell you the true story about the atom bomb.
Okay.
When it became obvious that an atom bomb could be invented, the Jewish physicists in Germany, and you can check my story with David Irving.
Okay.
The Jewish physicists went to Adolf Hitler and they said, "Do you want an atom bomb? We can destroy entire cities. We can slaughter hundreds of thousands of people with one explosion."
Wow.
And Hitler said, "The German people don't want anything to do with anything as disgusting as that."
Right.
So that's when the German physicists fled to the United States, and they went to talk to that screwball, Franklin Delano Roosevelt.
Right.
And Roosevelt said, "My God, I can destroy an entire city with one bomb?"
Right.
So, and that's what the beginning of the Manhattan Project was.
Mm-hmm.
See, so the idea of E equals mc squared, Einstein started chalking that up on walls everywhere he walked. He'd have a piece of chalk and he'd write that up on a wall because he wanted to provide jobs for Jew physicists who wanted to explode the universe.
Right.
And that's why Jewish physicists left Germany. They would have given the bomb to Germany. Hitler only started atom bomb research after he was certain that the Americans were working on it.
Yes.
Don't forget, the Germans never had a strategic bomber.
Right.
They only had tactical bombers that did pinpoint bombing raids. The idea of bombing a city and slaughtering civilians by the thousands,
Yes.
that goes back to the Lindemann Memorandum,
Yes.
which was a Jew physicist wrote a memorandum to Winston Churchill.
Yes.
And it's worded, these are the exact words. It says, "Dear Mr. Churchill, if we drop bombs on the German cities, the German people will hear the bombs whistling in the air, and they'll run out of their houses, and the bombs will drop on the houses and the churches and the schools and blow up the buildings, and they won't kill the German civilians." And Winston Churchill said, "Well, sure, if E equals mc squared, that must be true too." You see, so it's the same. What do French people say? The more things change, the more they stay the same. See,
Yeah.
So in other words, the screwball, the E equals mc squared formula, that was the gateway to getting the United States to do atom bomb research, see, to slaughter cities.
Right. Yeah, and it's a fact that the British under Churchill were the first to begin saturation bombing. All we hear about is the blitzkrieg by Hitler's troops, but the British began that policy, not the Germans.
Yes, in fact, concentration camps, I understand that concentration camps were original to the Boer War.
Oh, yes.
And that was, again, another English invention to put people in concentration camps.
Yes, under Jewish influence again. Yes, absolutely. So, okay, so this concept that the c being the speed of light is not a constant, and it depends upon the medium. What about an upper range for it? Is it an unlimited range for the speed of light? Because if space is indeed a vacuum, wouldn't there be some? Would there be no limit on its speed when it goes through a vacuum?
Well, see, if that were true, then the temperature of the sun would be infinite. Now, is the temperature of the sun infinite, or does it have a real?
Yeah. Okay. It has a limit, obviously.
Okay. So, in other words, the limitation on how quickly an electron can move from place to place depends on how intense the field is.
Okay. All right. So it sounds to me then that there's still some sort of resistance happening to keep it from running at an infinite speed. Are we talking about